Welcome back in, OregonArc students. We're on our fourth combinational integrated circuit. And actually for this one, before I dive in, I'm going to talk about the motivation a little bit. So the reason why we go this way, it's called a multiplexer, this circuit. Multiplexer lets you pick between multiple different inputs. So the idea here being that if you have two different inputs into a circuit and you want to pick one of them to output, then you'd need the circuit. So your question might be, well, why would I need to do that? Well, I'm going to actually give you a preview of the project a little bit to talk about why you might need to do this. When you really dive into this first part of the project with the ALU, you'll see that one of the key features, one of the interesting things about it is that an ALU, which is, again, this first thing we're going to dive into, this arithmetic logic unit, when you dive into it, what you're really going to end up doing and what you're going to end up seeing that the computer does all the time, because once you set up these circuits, they just run, is that the ALU lets you do different math operations. So it can either output 0, output 1, output A, output B, negative A plus B, A and B, A or B. All an ALU does, and it's a really essential piece of our CPU, is calculate all of these. In fact, whenever you give any inputs to your ALU with A's and B's as inputs, it actually calculates all of them. And then really all it does then is let use 3 extra pins, these N0, N1, and N2, to choose which of these 8 different inputs do I actually want to output. So all of these are actually calculated simultaneously, and we just create a circuit to pick which of these is actually going to be the output. So the ability to select between a number of different choices and only output one of them is pretty essential in the functioning of ALU, which is a critical piece, as you'll find out, in the functioning of our CPU. So for our example here, we're going to start with a simpler version, the full ALU. This will be a good starting point for your ALU where you'll be able to build on these things. So the idea here is you're going to have 2 different inputs. So let's call these, let's see here, N0 and N1. Go ahead and drag out some labels as well. N0 and N1. And the idea here is that you pick one of these 2 to go to a single output. So you're really reducing 2 inputs down to 1 output. So this is our out. So imagining in the ALU there's an option where you might output A or output B. We'd like to choose one of these 2 things, whatever they are, to be output. And so actually to make this happen, believe it or not, we actually need a 3rd input. So I'm going to call this my select, or SEL, which is short for select. I'm going to rotate it. Typically when you have a select pin, it's on a different side of the chip when you draw these diagrams to help you see its purpose a little more clearly. It doesn't have to be sideways, but you certainly can, and it is typically done this way. And so I'm just going to label a select. So the idea here is that the output reflects whatever the inputs are. So to make this happen, we'd first need to think about, all right, well, I'd like this output to reflect the first input if the select pin is 0. So if I select 0, then N0 should be what shows up as the output. So I need a NOT gate here. And so let's take a NOT gate to our select pin. And let's see, let's line this up. So if my select pin is 0, then whatever A is would go to my output. So we can kind of test that out, or whatever my N0 is would go to my output. So if I have a select of 0, then whatever I do to my input changes my output, and whatever I do to N1 doesn't change the output at all. So that is actually the first step of something that we want. However, we'd also like to say, well, if my select pin is a 1, so if I run select straight in there, and I guess just to be, I'm actually going to make sure it's very clear that this is not going through the NOT gate. And my input is 1, and my N1 is 1, I guess. Then I'd like that to route out to my output. But, well, wait a second here. I can't route two things straight here. What would I need to do logically to make this work? If select is 0, then whatever happens on A should go through. And if select is 1, whatever happens on B or in 0 should go through. So what do I actually need? Believe it or not, actually an OR gate works here. And we'll talk about why that is in just a second. You could write the truth table out yourself on this, by the way. If you think about these three inputs and what should happen, that's probably a good exercise. I've been through it a few times, so I've run through this, but you can certainly make sense to try to make a truth table here. What should happen here? Well, if select is 0 and A is 0 or N0 is 0, then output is 0. And by the way, I never labeled my output here, did I? Oh, I did. I didn't actually add the label though. Okay, so let's run my out over here. So if N0 is 0 and select is 0, well then select is selecting my N0 and N0 is 0, so my output is 0. However, if select is 0 and N0 is 1, then out is 1. So that's great. So this is reflecting what it should, right? Select is 0, so whatever happens with N0 happens to my output. I've selected this one N0 to be the thing that shows up as output. On the other hand, if select is 0, N1 should not change anything. And it doesn't, right? If it's on and N1's on, then output's on. All that matters is what N0 is, if select is 0. If select is 1, I can do anything I want to N0 and nothing changes on the output because I'm ORing 0 with whatever N1 is. If select is 1, however, then whatever I do to N1 changes my output. So this does what I want it to do. It lets me select, if select is 0, whatever N0 does to be my output. And if select is 1, whatever N1 is my output. And N0 has no effect. Right? So this effectively allows me to select which of these two things do I want as output. And so that's it. That's what a multiplexer does. It lets me use one bit to choose other bits. When you create this circuit, so I highlighted everything, clicked to create an integrated circuit. You want to usually put the select pin up top. And your ends could be A and B or N0 and N1. Whatever makes sense to you is completely fine. I think in the project I ended up using A's and B's, so I could use A and B. And so we'll call this a mux, which is short for multiplexer. And that's it. So we've created our multiplexer, which I'll call a mux. It lets you select which bit you want to reflect on the output.